This alternator has a separate, an external voltage regulator. So this is the harness that goes to the voltage regulator. I believe I can get a new one of these. I think I'll probably have to get a new voltage regulator. We have our voltage regulator. So when we did the wiring on this truck, we started it up with the original alternator and the replacement voltage regulator. The alternator didn't work. It wasn't putting out anything. We need to resolve that, and I'm shooting this after I have resolved it. This was never intended to be a full-length feature video, and as you'll see, this was just a complete pain in the rear. And part of the reasons for that is, well, this engine doesn't belong in this truck. We don't know what the engine came out of. We don't know much of anything about it except what we're going to discover as we move forward here. So this, for me, was a very long, painful video. I'm going to shorten it as much as I can for you, and hopefully we will get this resolved and get a working alternator in this truck. So that's where we're going with this video. Let's get into it. Okay, alternator. I took this off because these are hideously expensive with the vacuum pump output. Even though this is only a 50 amp, it's expensive. And I don't know, I'm going to take it apart, clean it, check the coils, and I don't know. So first thing is, got to take this vacuum pump off so you can turn it more easily and check resistance and things like that. Okay, there's our vacuum pump. Hopefully we managed to preserve that seal. It's pretty crusty in there, but the coils might be okay. I don't know. Let's see. Oh, that's goodness. That's I'm surprised that was turning at all. Let's see if we can. All kinds of junk falling out of this. I don't know if it's seeds or probably rat droppings. Why they would choose to live in the alternator, I don't know. Plenty of better places to live. Oh, it's just so grindy. The bearings are shot. I don't even know. So much junk is coming out of this thing. Something was living in here. I don't think this is going to be salvageable just because whatever it was, I think, that made it its home, mice or whatever, I think the corrosion is just going to be too much. They urinate and get all that junk down in there. There's not a lot of going back from that. Why aren't you coming out here? Goodness, it's just so wedged in there. Yeah, I'm not seeing good things. Just so corroded. This is a losing battle. I don't know about this. A really good shop could rebuild this, but one, can I get the parts for it? I think I'm gonna need parts. I can't imagine that I'm gonna get off scot-free on that. Completely. I don't think this is coming apart any more than what it is. I shouldn't be beating on this because you know, we risk breaking all your insulators, and at this point I'm kind of at the I don't have much to lose point. Oh, it is so corroded in there. It just wasn't locked together with years of mouse urine. If I could get the rotor out. Well, we have a new alternator at a very exorbitant cost. These things are not cheap. I guess, you know, the main difference between a regular alternator is, well, the pulley's a little bigger. That's fine, you can swap out the pulley. By that I mean it takes a bigger belt. I mean, it's obviously has 2 grooves, but it takes a really wide belt from these diesel engines. And it has the shaft for the vacuum pump drive, and the rear casing is built to hold it and all that. Other than that, I don't know quite what makes it so expensive. I mean, it is a 12 volt, just a 50 amp. It's nothing exceedingly large or special, so. But we have one, and I have a lot less money now. We need to figure out how to hook this thing up electrically. I still haven't figured out if this is internally or externally regulated. I asked the company that sells them, and they haven't got back to me. You'd think they would know. I don't know. I actually asked them at the same time I bought the alternator, and the alternator is here, and they still haven't replied to me. So that's the kind of customer service you get in today's world. I mean, they shipped it fast, but, you know, I would also like the answer to my question. You'd think it'd be easier to answer a question than ship something. Yeah, so just like the old one, this has oil holes in the shaft. I don't know if that means that oil goes through the shaft and lubricates the bearings inside here, or I don't know. I'm curious. If anybody knows that, leave it down in the comments. I'm kind of curious if these, I mean, maybe it just comes out goes in here and comes out the end of the shaft. I don't know, but does it lubricate any part of the interior of this? I'd be curious to know, because that would be a big difference between alternators and one of these, I guess. Anywho, so we have the same 3 connections. I've ordered a plug that'll work with this socket. It's a very common Denso plug. So, yeah. I don't know, I can kind of see the wire colors there, but don't know that helps me much. I can't really find a pinout for this plug, and even if I did, I wouldn't know for sure whether it was this exact alternator, because there's 2 different pinouts. There's one for an internally regulated and one for an externally regulated, and we need to know which it is. Originally, this truck had an external voltage regulator on the fender, and it was, you know, kind of hooked up. Some wires were broken and stuff, but so I had assumed it was externally regulated, but I'm not 100% certain. It does have an E mark on here for earth, which is one of the hallmarks, and there's some E stamps on the casing, obviously, because the case is grounded, which is usually a hallmark of an externally regulated. Usually they use the EFN terms, earth, field, and neutral. That's what those stand for, but that's the terminology they use generally, because it's just, there's no regulation or diodes or anything in here. It just outputs the coils directly to the plug, and then you use an external regulator to control that. We'll put this on, get it set up, and then we'll focus on the wiring. So the pigtail finally arrived, plugs into our alternator. We're going to splice these into the proper configurations using this alternator output. Basically, earth is at the top, field is going to be closest to us, neutral farthest away, so it means earth is black, field is green, and the neutral or stator is yellow. So I pre-traced these from our voltage regulator. I checked all this and verified it, and we'll just hook these up, and then our harness will be ready. Okay, got all those spliced in there, and again, we won't worry about making this look nice with wire loom or anything until we know everything works, because I've probably already done 3 things wrong here. But yeah, now we know the rest. I think we know the rest of that works, but we'll wire loom everything all at one time. I still have to resolve this washer pump, but that's fine. We know that works, but I think I can wire loom what I have. So if the alternator works, then I think we can wire loom and clean up and make this engine compartment look a little nicer. No alternator. Alternator. So we're on second voltage regulator. Now I had replaced initially, the voltage regulator I chose was what the previous builder had put on here. And I guess it wasn't the right one. Anyway, I have no way to verify if it was the right one, but
I'm more certain that this is more possibly the right one. So this one has a more definite field and neutral connection. The other one I had, it was kind of vague as to which the field and neutral connection actually were on the regulator, even though supposedly the manufacturer said which was which. But when you actually look on the voltage regulator, there were like, the pins were like ignition 2, 3, 4. And usually that type of regulator is the kind that the field and stator, well, it doesn't matter. They're just like 1 and 2, you know. Anyway, the end result is I don't think that one was correct. So I think this one is correct. The one wire I'm not using is for the warning light. I don't have a warning light on the dash. I could add one. Maybe I will. But at this point, I have a volt gauge. So if you can't read a volt gauge, then, you know, you shouldn't be doing operating vehicles anyway. All right, I'm gonna try to start this up, and I guess we'll hope we don't fire anything this time around. I just want to note real quick before I do this and light anything on fire, the pinouts I'm using for all these plugs are direct from the manufacturers of, or suppliers of, either the alternator and the voltage regulator, and I made sure to verify so that I'm hooking it up according to what they say. Am I really? I don't know, because nobody actually seems to know anything anymore. Or if they do, they won't put me through to someone who does. So, I don't know. Let's try this. So one of the tests you can run to test an alternator is to basically supply full battery voltage to the field coil. And if the output goes up, if your battery, you know, output goes up, then it works. I output voltage to the field coil basically this way to pretend to be a voltage regulator, only without the regulation. And I put a pin between those two wires, and just like before, it shot the battery down to 11 volts and heated up the wire. So of course I pulled it. Something is hooked up wrong, but since I have everything hooked up according to what the manufacturers say, either the stator or field is reversed from that plug that they're talking about, or my pinout on the voltage regulator is wrong. I don't think my pinouts on both voltage regulators were wrong. It fried the other voltage regulator, and it shouldn't have. I mean, it may have just not worked, but it shouldn't have fried it unless something was hooked up wrong. And I wonder if they're telling me wrong about that plug there. I mean, I'm afraid to hook it up the other way because they haven't told me yet, but they're just kind of ignoring me. They're not getting back to me. I was like, can you double check that that plug diagram that you gave me is correct? And they don't reply. This is the kind of customer, this is an American company. They're down in the south of Florida, and I'm in North Florida, so you'd think they would have a little bit more better customer service, but they don't. Something I'm going to need to resolve in the future is the ignition switch sticks a little bit in the start position. If you don't manually pull it back off of start, starter will keep running, and I think that's due to the rod. There's something, I'll get to it in the steering column video, but to modify this, I think it's the rod is rubbing on something a little bit. It'll probably wear in over time, so I'm not going to worry about it too much for the moment. Just as long as you know about it, you can pull the starter back. But I found that out the hard way by realizing that the starter was running after the engine was running. So yeah, what to look at next. So the goal of this video was not originally ever intended to be about how alternators work, or, you know, the differences in alternators or any of that business. The goal was to just show retrofitting, you know, getting this thing working and retrofitting a voltage regulator to an older style alternator. But I think to describe how difficult this is getting, I need to get into a description of basically the root cause of the problem that I'm facing here. So this is an old engine design and an old alternator design. And originally, generators and old alternators had a separate voltage regulator, because an alternator or a generator will, put out basically as much as it can all the time unless you regulate it. Modern ones have either an internal voltage regulator or it's incorporated into the computer now so that the computer can manage it easier. And I'll describe that a little bit better, why that's better for voltage regulation but worse for maintenance in a minute. So this is the bare basic of alternators. It is externally regulated. The only thing it does is internal rectification. So anytime you have that spinning motion, you are creating alternating current, but you need to convert it into direct current to operate in the vehicles, because our vehicles operate on direct current DC. So I'm not going to get into the basics of sine waves and all that stuff, but so we take alternating current and convert it to DC current, and that's the only thing that this alternator does. That's why it's called an alternator, because it alternates. Anyway, so the outputs and inputs of this alternator are basically, you have a ground, you have the output for battery voltage, which that's what the B stands for. Basically, this is the output pin on the alternator. This is where the current that it outputs is coming out from. And then you have a ground, a field, and a neutral or stator connection that go into the alternator from the plug. So the body of the alternator is always grounded. I don't know why they run a separate ground. I could have just run it here, but I didn't. I ran it all the way back to share the ground with the voltage regulator, because that needs a ground also. So you have the stator connection, which basically there's two sets of coils in this thing. There's the rotor, which is the inside that rotates, and there's the stator, which is stationary, doesn't move. So the rotor is basically the field coil. You have to supply some kind of voltage to get a magnetic charge out of that to get it going, because you can't just have motion. You have to have motion and that initial electromagnetivity to get it where it actually creates power. This isn't perpetual motion, so you can't just have the rotation. You need to fire some voltage into that so that it energizes the field coil, creates the magnetic field, and then it will output power through the stator coils. So the stator connection that you have access to, that the pin comes out, is the center point, and this is like a Y, what's called a Y configuration. There's basically three coils, and they're connected at the center, and each one outputs a phase. So that's the way this one works anyway. There's also delta style and everything, but generally the Y configuration is used in these alternators. So as it passes each one of those three coils, it creates a wave, and that creates our alternating current. But we rectify that through diodes, so it only takes half of that, chops it in half. It only takes either above the positive line or below it, accordingly. Anyway, then we get that direct current, which is a positive 12 volts instead of going back and forth like alternating is. Anyway, that's the bare basics of that. That was probably way much more than I intended to do, and you can easily look that up online. That was probably a poor description. Anyway, we are working with the bare basics. This is not internally regulated, and we don't have a computer to regulate it, and I don't know, as you've seen, what regulator is supposed to be used for this thing, but there's a couple different styles of regulators for these external ones, and they all do basically the same, but some of them do slightly different. So the goal of the regulator is to output to the field coil a specific voltage to regulate how much current this will output. So the more voltage you feed it, the more current it will output. Obviously, if your battery is fully charged and your system isn't drawing any power, you don't need any current. So that regulator needs to pull that voltage way down so that it just maintains that basic 14 volts, 14-ish volts, and it doesn't have to output a lot of current. Obviously, because you don't want to damage your alternator and your system, and for efficiency, because you don't want to generate power when you don't need it, and it's just going to be wasted and not be able to be used by the system and just go into heat, and you know, heat's bad. So that's the purpose of the regulator. So some of them will obviously have the internal regulator mounted in the alternator or inside the case. This one doesn't, so we have to control it through the external side. So the way it determines the regulator, the way it determines how much voltage to feed that, there's a couple methods. You can use a computer, and this is why the computers are better, and graduate it so it's continuously, you can feed any amount of voltage based off of what you need, anything from 0 to 12 volts that the battery is putting out. You can feed to this to get an infinitely variable amount of its capability, you know, up to its maximum capability. That's what you can get out of it. A solid state regulator, like we've been using, you can have a couple settings inside. Like say you could output like 2 volts and 6 volts and 8 volts and 12 volts, and you could have various steps, or you could just have 2 steps on and off, like a switch. So you get no current or max current, or you can have off, or you can have low current and high current, things like that. You can have various steps and settings, and that's all determined by your voltage regulator and how it's built, because it's all obviously internal to the voltage regulator, and unless it's completely digital like your computer controlled ones these days, you have to rely on the internal components and the built-in steps that they provide. I think the one we're using has like 3 or 4 steps. I don't remember exactly, but it's supposed to be for these vehicles of this era, and these Nippon Denso, or Denso as they're called now, alternators. It's supposed to be. I don't know, but the main difference in these regulators, I'll get to some other, I'll get to another difference in a minute, but the main difference, the biggest one probably for the variables of these, is those steps and how much regulation capability it actually has. The second one, it's also big, and I don't want to lower the importance of it, is that there's 2 basic types of regulation. This is a type B circuit is what it's called, B circuit and A circuit. So the B circuit just regulates the positive connection to the field coil. It just feeds a different voltage to the field coil. The stator is just a reference. The only thing it does is look at that for, you know, reference, see what it's putting out, basically. Just the simplified version of that. The A type, that's they're built a little bit different, because your stator and field are not specific to positive or negative. So it regulates, basically they call them pin 1 and pin 2 rather than field and neutral, or field and stator. And that's because they're basically interchangeable, because it's all controlled inside the regulator. It's basically, it'll control both sides of the field coil, the positive and negative, and since that doesn't matter which is positive and which is negative, then it will, you know, not matter over here. So that's why I just call them pin 1 and pin 2, because it doesn't matter which end of the field coil you're talking about, because you have access to both ends. Here we only have access to one end of the field coil. The other end is always grounded. So I know there's probably some small errors in what I said there, so don't blow me up in the comments, but that's the bare basics of what I'm dealing with. So this is, we know for sure this is a B circuit alternator. Well, the manufacturers told us. We know what the pin out of that is, and so we know that we need to control, to regulate this alternator, or even get it started to energize the field coil. We need to supply power on this cord. Now this is what full fielding does. It's just a basic test. You just take this wire and touch it to the battery, and that supplies maximum voltage to that and says, hey, put out all you can to the field coil, to the alternator. and that's what it does. And you should see your voltage and, you know, amperage output rise. I'm not sure if that's what we're seeing because I'm not sure I did it right. I wasn't checking amperage. All I was looking at was voltage, but I didn't see the voltage go up. To do that, I should have been checking like amperage on this wire with like an amp clamp or something. Maybe I'll do that, I don't know, but we can do some checks with this off. We can see if the voltage regulator is working independently, because when we power it on, regardless of whether it's hooked to the alternator or not, when we power it on, it's looking at battery voltage and what's coming out from the alternator. And if it sees nothing coming out from the alternator and a, you know, mid to low battery voltage, like 12 volts, which is lower than the requested 14, it's going to output at least some voltage to that to get it to catch up and supply some amperage to the circuit. So we should be able to do that with this disconnected. So we should just be able to pull this plug here, put a meter on this field wire, which is the green one on this plug in this case, hook up our voltage regulator, which I don't know what I did with it. I have to find it. I'm also going to put a reference. I wasn't going to, but I'm going to put a light on here. It also acts as a load, so that may be part of the reason it's not working. This particular regulator may require this load as a reference. I don't know. The way this works, this lamp circuit, is you hook a lamp up to this and the other end of the lamp to 12 volts on your battery or your ignition. So when this is on, if your alternator is supplying power, this line will have 12 volts and the other side of the light will have 12 volts, and then the light will go off because it's not grounded. But if it's not putting out power, this line will be grounded, and obviously the other side has 12 volts, so the light will come on. That's just the bare basics of how that works. It's just like an internal switch inside the regulator that it's using for reference. But like I said, I don't know if we need a load on that or not. Some regulators use that as like a reference load, kind of like a resistor, basically. I don't know. It could be part of our problem, but we can play around with this without actually starting the engine, because we can see what the alternator, what it wants the alternator to put out by putting a meter on that. So sorry for the long TED talk. It probably has, you know, some wrong information in there, but the bare basics of it is correct, and that's what we're dealing with. So I need to run some tests here and see what's working and what isn't. I have tested the field and stator ohms with a meter, and it seems to be within, you know, roughly within what the factory spec should be for this, because those are the specs they give you to see basically if the coils are roughly okay. You just put a pin on there, a meter lead on either the field or the stator, and then the other meter lead on the case, and you see what the resistance is. I don't remember exactly what we're getting, but we're getting, I think it was like 0.1 ohms on the field and like 20 ohms on the stator. I think spec is actually a little higher than that, but we're not getting like infinite, and we're not getting a real high resistance, so I guess that's okay. And this is brand new, and I shouldn't have done anything to it that's capable of frying it. The only thing I can think of that might be fried would be the diodes for the rectification process, but I mean, it's been hooked up a very short time to any of these regulators, so I don't know. It's kind of hard to fry these things directly. I mean, if you hook them up wrong, you can fry some things, but an internally regulated one is a lot easier to fry because you can fry the regulator portion of it, but this doesn't have that built into it. So if the coils are okay and the diodes are okay, you know, then it's going to put out something. We just, you know, the brushes might get worn or things like that. It might put out less, but it should put out something. This isn't putting out anything. So next step, hook up our regulator, run some tests. Enough talking, let's do that. So before you say, well, his voltage regulator isn't completely hooked up, this bullet connector here is for a radio noise suppressor. It's basically just a capacitor. It just smooths the DC signal out a little bit. We don't need that for what we're doing. So I've hooked this up. I don't have the ignition on, and I got my meter plugged in here. It's connected to case ground on the alternator, and I'm connected to the field pin here. And 13 volts. Our battery's probably at 13 volts. I mean, obviously. So it's requesting 13 volts with the ignition off. It's not a good thing. That'll run your battery dead. Now I'm wondering about this voltage regulator. I mean, the ignition's not on because I got the keys right here. What happens if we turn the ignition on? Let's find out. That's not right. Okay, ignition on. .6 volts. Okay. I mean, that's about right. It's not excessive, but it should be enough to excite the field coil and get it going. I'm gonna have so many splices in this stupid thing because the wrong information people are giving me. I'm gonna have to start all over with this wiring harness. I should just be using alligator clips and everything to kind of temporarily do this, but then you risk shorting stuff out, especially when you got to start the engine and there's vibrations. So that's the main reason I'm not doing that. Well, this is ridiculous. I don't know what to do with this now. All right, alternator. So I went ahead and got the one wire version of the alternator with the vacuum pump. And I didn't do this right out of the gate because there's lots of unknowns here. I don't know what this pump is rated for volume-wise and pressure-wise. Will it be enough to run what I want to run? I don't know. This is a slightly different pulley. Not only is it 3 grooves, but it's a smaller diameter pulley, which means it should run a little faster. But this doesn't. They sent me specs for this alternator, fortunately. It doesn't even spin up until 1,120 RPM, which I assume is at the alternator, but that's probably about 600 or 700 RPM because of the pulley reduction. I don't know, I'd have to do some math on that, but it should spin up relatively soon on our engine. That's not an issue. The main issue is, so now we would have our wiring resolved because it's one wire, but the vacuum pump, this is a banjo bolt on the old vacuum pump. As you can see, the oil, this is the oil drain return. This is the vacuum. This is the oil in, oil out. Not only is it a just not banjo bolt, it's just a barb, but it's not even, it's for a huge hose. And even the hose that I have for the banjo bolt is this size. And I was like, well, I don't want to cut it because it's going to be impossible to get a hose like this. I'd have to have it custom made with these banjo bolt ends, and I'm at my wit's end here. I'm running out of options. I'm either going to have to thread some kind of adapter in here, or, I mean, the worst case scenario is I can put this hose back together with a, you know, barb junction union. But this thread, it's some kind of weird metric. I haven't bothered to measure yet, but it's not MPT or anything like that. Nothing I have in stock. I have to go to the hardware store. What a mess, basically, is what I'm saying. So I either need to find a barb that fits in here that I can actually adapt a normal size hose on without necking down 5 times. I mean, I don't want it to look ridiculous. Yeah, I can do all this. I can run all kinds of adapters and junk on here, but I want it to be right. I don't know. That's where we're at now. I got to figure this mess out. This will bolt up. I tested the bolt pattern and everything, but yeah, the vacuum pump is our issue. So I don't know. Let's figure that out. All right, here's my solution. Obviously, I'm going to shorten this to the correct length. Banjo bolt to engine return, oil return with a barb. And I have used this 3/8 hose. I've worked it down over this barb. Not even remotely ideal. I don't like this at all because it has the potential for oil leaks, especially as this gets old. This hose is overstressed. I don't like it. And I don't have much choice at the moment. it's a choice between wrong solutions, I guess, at this point. But out of all the wrong solutions, this one seemed the best with what I had to work with. I don't know. Again, we don't even know if this alternator is going to work, but it should because it's brand new, but I don't know. Let's put this in and get all this set up and all that junk. All right, in other news, my measurements here were slightly off. This one needs to be thicker, not this one. I think I need to take off a little surface area there. All right, here goes the warranty.
This is the way.
All right, a little bit of shaving there. Let's see if she fits. Oh, need some on this side. Let's see if I can cut some of that off without, completely destroying anything. Okay, this alternator is in. I don't know if it's in well. I'm pretty sure that the oil system is going to be nice and sealed up. This banjo fitting was interchangeable, so I just reused that because I preferred the kind of downward direction this points. I've got the wire to the battery hooked up. That goes up to that junction block and then to the starter and the battery. Anyway, it goes to the battery. I should probably run it direct to the battery, but I want to see what works here before I do this. And these two wires, one of them is not used. It says don't hook it up. And the other one is for your warning light. So I don't need to hook them up. When I go to start it, I will probably hook up a warning light just to see if the alternator is working. Basically, you just hook that light from whichever wire that is, which I'll have to look it up. I think it's the green one, and then to positive. You can just do that with alligator clips temporarily. I have the rest of the voltage regulator harness removed, and again, don't know what I'm going to do with this yet because, well, nothing is finalized. So we're going to, next time we start it, we're going to be ready to test the alternator and see if this looks like a smaller vacuum pump will output enough vacuum for us. It may take longer to build. The main difference is the depth of the pump. So the only way to know is to try it and see what pressure we can get on it. I forgot to mention, I'm glad I didn't do this right off the bat. I'm glad I tried the factory alternator first, even though I sent it back to the supplier and they told me the alternator was bad under warranty and they gave me my money back. And although they didn't give me all my money back, and they won't tell me what was wrong with it, so I kind of crappy on their part, because I mean, they kept a quarter of the price. They kept $100 of my $400 alternator just to ship me a bad one. And I at no point did anything to hook that alternator up wrong that would have fried the diode pack or anything in there. There's no possible way. I double and triple checked everything before I even turned it over. Anyway, that's beside the point. To get this in, I had to modify it a little bit. Turn this bracket down, shim it with this washer. If I turn it down, I mean push it down this way, because there's just one bolt holding it on up here. It kind of pivots. This alternator is a little bit smaller, and it's a little bit smaller this way, so between all the trimming and the adjusting, and I had to file my bracket down a little bit to clear the cooling fins on this, because, well, it sticks forward a little differently. It's a pain. It's a real pain. All right, it is test time. We are testing several things here. We are testing alternator function. We also need to test the vacuum pump, because the smaller vacuum pump might put out less vacuum. So now's the time, if that's the case, that we are going to find out about it. So we're going to test the alternator and this vacuum pump. I am not going to hook up a test light, I don't think. It's just not worth the effort. I'll be able to tell by the voltage. Yeah, okay. Let's do this. Okay, I think I have to hold the... Oh, let me hit the glow plugs for a second. All right, that was 15 seconds on the glow plugs. We are still not getting proper voltage. Vacuum, we are at 5 inches of mercury and holding. That's not going to be good enough. Definitely not going to be good enough. You see that alternator? It is spinning. But either way, this is not going to do the trick, because I was hoping, after I saw the vacuum output on that last pump, I was hoping I would be able to use vacuum brakes, or a vacuum brake boost assist, and that's not happening here. I'd asked several suppliers of this unit what the vacuum output was, or what it was rated for, and no one could tell me. As is with parts suppliers these days, no one knows anything about what they sell, and they are unwilling to look it up or check into it. Well, that's disappointing. I don't know if I can put the other vacuum pump on there because it's different. Not sure. Alright, not happy with the vacuum unless my gauge is wrong. I should have checked that it returned to 0 before I started it, because sometimes it does. Okay. Yeah, I don't know. Alright, I'm going to hook a test light up to that alternator. Not a test light. I'm going to hook what would be the gauge light up to that alternator. Sometimes you just got to drink your coffee out of a mason jar. I don't know. Welcome to the South. Cold day, coffee in a mason jar. Approved. Okay, I've got a test light hooked up there to what is, according to the diagrams, the light terminal. Alright, let's start this thing up. Yeah, see, the vacuum did not... Come on. This vacuum gauge is... Okay, there you go. It doesn't like that pin there sometimes. Alright, let's start it up. Now we're getting... It was the gauge, now we're getting more vacuum. 13.6. It must need that. Oh yeah, okay. That light is the exciter wire for the alternator. You have to have that hooked up. Alternator's working. So we're getting 15 inches of mercury. That should be sufficient for brakes. 13.6 volts. 13.8 when I rev it. Good voltage, what I would expect, not quite 14, but I mentioned the lower RPM. I think this alternator is spinning at a lower RPM probably than what it's made for, but because of the pulley differences, and this alternator is made for an engine with a different pulley. I don't know what size, but a different one. I may be able to put the other pulley on, but for now I'm going to leave it because I'm getting voltage and that's what's important. Okay, we're getting almost 16 inches of mercury. That will be sufficient. I can deal with that. Now, I just want to make a note. This is not even remotely the right way to do this. I wired a light in line with the alternator generator light circuit, whatever the technical name is for that light, because it's, yeah. Normally that would be in the cabin. The problem is I never ran a wire for a generator light because I didn't think I was going to need one or want one, because I have a voltage gauge. usually when you have an amperage gauge and, you know, then you want to know if your generator is actually working or if your needle's just straight up and down and you're not pulling anything, you know. But in this case, we don't really need it. The only thing we need it for is kind of a little load on this circuit. I'm not even sure technically if we need an actual load, but it shows it on the diagram, and I want to do this right. So yeah, let's test this thing. So when I put the key in, this is wired to ignition, the same ignition that was going to our voltage regulator. So when I put the key in and turn it, this light should come on, and then when I start it, it should go off. So that's what we'll be looking for. Okay, got our batteries hooked up. Ignition, so we should have a light bulb. And we do. When I do that, I don't know, leave it stick out of the wire loom or something. I don't know what I'm gonna do. Okay, let's start her up. Give her some fuel. All right, 13.8 volts. Light should be off. And it is. Okay, alternator is a success. Finally.
So a lot of this video got cut out along the way because it was just starting to, you know, get really boring. And what's left is probably still long and boring, but it's the highlights. And this is part of what you get when you work on old vehicles, and especially when you retrofit engines in to older vehicles or even newer vehicles like this. Things don't match, but that's part of the hot rodding game. So I actually kind of enjoy this kind of thing because it's a lot of troubleshooting and working through problems and research, and that's kind of what I'd like to think is one of my strong points, but it turns out to be incredibly boring on video, so a lot of that stuff got cut out. Anyway, the end result is we have a working alternator here in this truck, and that means we are one step closer to getting this thing back on the road. So I promise one of these days it's coming. We're working toward it. That's our goal. Nobody wants it more than me, I can assure you. But anyway, feel free to leave a comment down there below. Hit that notification bell. That does something. Please feel free to subscribe. It's free. It doesn't cost you nothing. Certainly makes me happy, and I greatly do appreciate it. And as always, thanks for watching. This airplane go over. Oh my goodness, could you possibly fly any slower?